Today we are going to learn about continuous random variable. Okay, so first of all, continuous random variable is said to be continuous if the set possible values in an entire interval numbers, that is, for example, if we have a less than b, so a less than b, any numbers between a and b is possible. In other words, for continuous case, the random variable can take on values on continuous curve. For example, we have a is 1 and then less than 2. So it can take any values. For example, we have 1.9999 or maybe just 1.5, 1.25. So any numbers between the 1 and 2. So this is what we call as continuous random variable. And then for 3.31, we have probability density distribution, definition 3.5. A function values fx defined of a set of real numbers, of all real numbers, is called a probability density function of the continuous random variable. Only and only if. So we have the probability of a less than equals to x less than equals to b equals to, you need to integrate, start from a up to b, and then you have the function towards dx. So for any constant, real constant a and b, with a less than equals to b. And the probability density function are also referred to as probability densities, or PDF, or densities. So we have several properties. The first one, the property for the first one, for function x must be greater or equals to 0 for any range between to negative infinity less than x less than infinity. And then this is also the same as discrete random variable. If you integrate the function from negative infinity to infinity towards the x, you are going to get 1. And then the next theorem that we have, if x is continuous random variable and a and b are real constant, then if you notice the inequality, the symbol over here, if you less than equals or less than equal or less than equal, this is also the same. So there's no differences between this symbol. If you want to compare it with the discrete random variable, for discrete random variable, it is different. For every inequality symbol that we use, it is totally different. Why? Because for discrete random variable, we have only 1, 2. So the number in between is not included. But then for continuous, when we have 1 and 2, 1.9999, everything is included in the function. So this is the difference. That's why in the inequality symbol used in discrete is very sensitive, but then if you use the continuous random variable, the inequalities is almost the same. Everything is equal. There's no really differences between numbers because it is continuous random variable. Alright, so let's do the example. Example 3.1, this is actually to use the properties. The first properties, which is if you integrate the function start from negative infinity up to infinity, you are going to get 1. So this is also if you have a question asking you to prove whether it is a continuous random variable or not, so you need to use these properties. So the function that we have here is cy squared. So you need to integrate, start from 0 up to 2. So you just need to replace in the properties that we have. So since the limit is 0, the lowest is 0, so up to 2, and then this is the function, and then it must be equals to 1. So you integrate, if you remember, for integration, so cy square are going to be cy cubic divided by, to the power currently is 3, so divide by 3. And then the limit is from 1 to 2. So you need to replace the limit. This is actually c to the power of 3 minus with, you need to do some changes over here. This is actually start from 0, so the limit should be 0. So c 0 to the power of 3 divided by 3, so that's why you're going to get. So the answer should be 8c over 3 equals to 1. So c is actually 3 over 8. So this is the answer. So this is not the correct one. Okay. So for example 3.15, this is find the value of c. So we just need to refer to the function. So we have c over 2. The limit is from 0 to 4. So you just need to integrate the value. So c x over 2, start from 0 to 4. So 4c over 2 minus with 0. This one equals to 1. So c would be 2 over 4, which is 1 over 2. Alright, and then you need to solve for the question. For B, we have probability x less than 1 over 4. So after you solve for the question A, you need to replace C in the equation. So by right, if the question asks you to integrate the value less than 4, it is going to be less than 1 over 4. So the lowest limit that you have is actually 0. So C, we have this C. C is actually 1 over 2. So you need to write 1 over 2 over 2, integrate towards the x, and the value would be, so you are going to get 0, 1 over 4, so 1 over 4 dx. So x over 4, the limit that we have is 0 up to 1 over 4. So the answer would be 1 over 4 minus 0. So the final will be 1 over 16. So this is the probability for less than 1 over 4. So for the next question that we have, for C is the probability x greater than 1. So you just need to refer to the limit. So the limit, the highest is 4. So if it is greater than 1, the highest would be 4, and then the lower will be 1 lah. So the function that we have is 1 over 4 dx. So when you integrate the value, you are going to get x over 4, 1 up to limit 4. So you replace the value in the equation, you are going to get 4 over 4 minus with 1 over 4. So the final answer would be 3 over 4. Okay. So actually in the next page I already have you some of the key points that you need to write in your solution, so you can try it. I just gave you the answer just now. So for example 3.16, you need to do it yourself, just like what I did before. Okay, so the next one that we have is distribution function.